Hello, everyone. Welcome to our class. Today, we will focus on how to transit the virtual address to physical address to support the virtual memory system. So last time, we actually talked about some details of a page table. So with page table, we can kind of find out whether the data is on physical memory, the main memory, or is on disk, or the data is not there. So today we will focus on, okay, if we know there's a table and table tell us the data is in the main memory, how we find this data in memory, how to find the physical address of main memory to support this kind of data load and data store, this kind of process. So this is today's topic. So last time we talked about this, we have virtual address. This virtual address is something like this. We use part of virtual address to search the page table, and we eventually can find out there's some specific page table PTE, page table entry matched to this virtual address. And we can use the valid bit to make a decision to decide whether the data is on main memory, the RAM, or it's on disk, or it's not there. If it's on the main memory, we can use the address here in some way to support this address, like to support the physical address generating. Or if the data is not there, it's on disk, we can also use this address to support finding the data on disk. So right now we should talk about more detail about like how to find the address. And of course, we know we can use part of the address to find a page table entry. Let's talk about detail here, okay? So first of all, we have a virtual address. This virtual address has n bits, like let's say 32-bit or 64-bit. There's an n-bit virtual address here. And we split part of the virtual address to VPN, converged page number, and VPO, virtual page offset. So it's kind of like we split the address to two different parts. We use the first part, VPN. This VPN is the part we use to find the page table entry from the page table. So we use VPN, which has n-3 bits for this one, and other part is VPO. VPO, we only use it when we get the page table data. So first one, when we want to load specific data to registers, then the page table based register will be a notification. And this part will use your virtual page number to find the page table entry, your page table. So everything happen here. We need MMU, a special hardware device to support this like kind of search and finding. And after you got the VPN, use VPN as a kind of index to use some way to find the page table entry. Then what we want to do is, if we could want the data is on main memory, right? It's already on the physical memory, the RAM. So we use the information we stored on the physical page number. So the address stored on the table. We find which page in the main memory, which page in the main memory has the data we want. So because we want to search the data is in the main memory. So the physical page number tells us which page in the main memory, has this data. Then we use the physical page number and use the physical page offset, which convert the virtual page offset to physical page offset. We use it as offset to find the data in the page. So specifically, what we want to do is with virtual address, part of virtual address, to find the entry in the page table, then use the data stored in the table with the part of our virtual address together, which is VPO together, then we find the physical address in the main memory. So this is how to search the data in main memory. Another case, if the valid bit equals 0, if you remember, if valid bit equals 0 means the data is on, if there's an address there, the data is on disk, right? So we need to do a swapping, paging. We want to remove some data from memory and move it to the disk. And we need to move some data from disk to the main memory. So after you're doing this whole bunch of stuff, eventually you will still get the patch loaded into the physical memory, and you can still get the physical memory address for this. Okay, so this is the detail about how to transit from virtual address to a physical address. Okay, so this is kind of the summary of the whole idea. First of all, the processor try to find the data, and it uses a virtual address. So it sends the virtual address to MAU, this hardware device. This device try to search, so it will generate the PDE. So the generate PDE and try to find the data on the page table, because the page table is stored on main memory. So it uses this PDE address and find the table on main memory, and the data will tell you, okay, it will return the PDE itself, so including the valid bit and some address information to the MAU. The MAU will use this information and also use the virtual part of virtual address as offset, try to find the physical address in the cache memory, because it's a hit, the data is there. So it's just use this data to find the specific physical address for the physical memory, the RAM, then load the data on this physical address to the processor. This is the whole process. If it's patch missed, the processors also send a virtual address to MAU. MAU also try to get the PDE address from the cache, try to search the table in the memory using the PDE address, and it will return the PDE to the MAU, and PDE shows that the value equals 0. So what it needs to do is it's called a patch fault handler to handle the swapping, paging, and so on. Then at the end, you will copy some data from physical memory to the disk, then copy the data from disk to the physical memory. Eventually, you will still get the right other like physical address there. Then you will return everything to the process, and process will still to do everything is needed. Okay, so this is for today. Today we talk about the details about how to convert the virtual address to a physical address. Basically, we split the virtual address to two parts, one called VPN, one called VPO. VPN is the kind of the index or the information we need to search in the page table to find the corresponding PDE, page table entry. And we use the data, the information stored in the PDE, the page table entry, with the VPO together to find a physical address to search it in the physical memory, the RAM. If the PDE shows that the value equals 0 is page fault, then you need to do the swapping, paging before you access the data on physical address. Okay, so this is the kind of interesting process to do this conversion from one address to another address. Okay, so hope you enjoyed today's lecture and hope you take some lessons from today and get more clear view of how the virtual memory works. Okay, so see you next time. The virtual memory is